Hello all, welcome to Docker, Basics to Brilliance course. My name is Kastro Kiran. In the last video, we have seen how to work with the Dockerization of a Python-based application as mini project 1. So as a part of mini project series, in this video, we are going to look after mini project 2, where we are going to understand how to Dockerize the Java applications, which I am calling it as normal Java applications. First, we will understand how many types of applications we can develop by using Java programming language. And then we will understand the difference between the normal Java application and other type of application which we are going to see. As discussed earlier, in this video, we are going to talk about how to Dockerize the normal Java applications. But before talking about normal Java applications, we will see what are the different types of applications that we can develop by using the Java programming language. So types of applications that we can develop, using Java programming language. So I'm just keeping it as JPL, which represents the Java programming language. Using Java, we can develop the two types of applications. One application is known as without Spring Boot, we can develop the applications. Okay, without Spring Boot, we can develop the applications. And the second one is with the Spring Boot, we can develop the applications. These are the two types of applications that we can develop using Java programming language. So the applications which are developed without using the Spring Boot, they are called as the normal Java applications. Okay, the applications which are developed without using Spring Boot, they are called as normal Java applications. And the applications which are developed using Spring Boot, they are called as Java applications with Spring Boot. Okay, they are called as Java applications with Spring Boot. The applications which are developed without using Spring Boot, they are also called as legacy projects. Okay, they are also called as legacy projects. And the applications which are developed with Spring Boot, they are something which are commonly used in real-time scenarios. Okay, whatever the applications that are currently developed using Java programming language, they're all being developed using the Spring Boot. What is Spring Boot here? Spring Boot is actually a framework that is available in the Java programming language. For every programming language, we have different types of a framework. One such framework that is available with respect to Java is known as the Spring Boot framework. Okay, Spring Boot is one of the frameworks that is used to develop the Java applications. Now here, what we need to understand is based upon the type of application, whether the application is developed without Spring Boot and with Spring Boot, the Dockerfile components will also get changed. Okay, Dockerfile components will get changed, based on the type of Java application. Okay, based on the type of Java application. We will see what is the component that will get changed and how we can work with that component, that we will understand now. All the normal Java applications, whatever that are there. Okay, remember, normal Java applications are something which are developed without using Spring Boot, that we know. Okay, normal Java applications are developed without using Spring Boot. So all the normal Java applications will be packaged. Okay, will be packaged as a war file. Okay, will be packaged as a war file, and then that war file, will be deployed into the web server. Okay, into the web server. So we have different types of web servers such as a Tomcat, Apache, and then Nginx. Like this, we have different types of web servers. So what we will do with normal Java applications, we are going to package it. Okay, we are going to package it as what type of file? As a war file. And then this war file, we are going to deploy into the web server. That web server can be a Tomcat, it can be an Apache, it can be an Nginx, it can be any other type. But here, what we need to understand is if you want to package, okay, if you want to package any Java applications, okay, to package any Java applications, to package any normal Java applications, we will use, a build tool. Okay, we will use a build tool which is known as Maven. Okay, which is known as Maven. If you remember, in the last session, I was telling that Maven is actually a build tool. by using Maven, what we can do, we can do the compilation. What is meant by compilation? Conversion of the .java file into .class file is known as compilation. Once after we do the compilation, we can also package the code either as a jar file or var file using Maven. So let me write that. So what is meant by compilation? Compilation is nothing but conversion of, okay, conversion of .java file into .class file is known as compilation. What is meant by packaging? Packaging is nothing but whatever the .class files that are there or whatever the .java files that are there, you are going to package it as a single file. Okay, package all the files as a single file. Okay, package of or packaging of all the files as a single file is known as packaging. Okay, is known as packaging. Usually for Java applications, we can do two types of packaging. One is called as a jar file, and the second one is called as a var file, and the third one is also there, which is known as EAR file. What does it mean by jar files? Jar file is nothing but Java archive. Okay, jar file is nothing but Java archive. So for what kind of applications we will get the jar files? For standalone applications. Okay, for standalone applications, we are going to create the jar file. Okay, we are going to create the jar file, or jar files will get created. For web applications, okay, for web applications, what file will get created is the var file will get created. Okay, for web applications, var file will get created. So these are the two things that we have to remember. Standalone applications will create jar file, web applications will create the var file. Now, currently, what we are going to see is we are going to see how to deploy the var file, okay, into the Docker container. How to deploy the var file into the Docker container. Now, here, one thing that we have to remember is for projects which are developed by using Spring Boot, we don't have to use the Maven. Okay, for projects which are developed by using, let me write that. For projects, okay, for projects which are developed, okay, which are developed by using Spring Boot, okay, by using Spring Boot framework, we don't have to use, okay, for projects which are developed by using Spring Boot, we don't have to use the Maven. Okay, we don't have to use the Maven. We will understand in detail about this particular statement in the next project, which is mini project 3, where I'm going to show you how to Dockerize the Java application, which is developed by using the Spring Boot framework. Okay, which is developed by using Spring Boot framework. In detail, we'll talk about this particular line, but currently just remember, for projects which are developed by using Spring Boot framework, we don't have to use the Maven build tool. What Maven will do, Maven can do the compilation, that is conversion of .java file into .class file. Maven can also do the packaging, where the packaging will be done with respect to jar file or var file. Jar represents Java archive. Okay, jar represents Java archive, and var represents web archive. Java archive and web archive. EAR represents enterprise archive. So these are basically, this file will basically come for enterprise based application that we are not going to see as of now. So this is about how to Dockerize the normal Java application. So the concept is, by using Java, we can develop two types of application with Spring Boot and without Spring Boot. Without Spring Boot, the applications are called as normal Java applications. With Spring Boot, the applications are called as Java application with Spring Boot. And this is something that is commonly used in the real-time scenarios. So currently, we are focusing on how to Dockerize the application, which is developed by using Java, which is also not used Spring Boot as the framework. That's called as a normal Java application. Okay, that's called as a normal Java application. So in order to deploy the normal Java application, that is without Spring Boot, we have to write a Docker file. Okay, we have to write a Docker file. So let's write the Docker file in order to Dockerize the normal Java application. Okay, the normal Java application. So in order to Dockerize the normal Java application, we need to have Tomcat. Okay, we need to have Tomcat server. So Tomcat server, okay, Tomcat server is required to Dockerize. the normal Java applications. If you want to Dockerize the normal Java applications, the Tomcat server is required. Okay, Tomcat server is required to Dockerize the normal Java applications. Okay, the normal Java applications. Now we will understand how to Dockerize the normal Java application by using Tomcat in the form of Docker file. Now, this project, okay, whatever the project that I am going to deploy, that is currently available in my GitHub repository. This is the repository that I have. I will give this repository URL in the notes also. You can deploy the same project, whatever that I am going to do in this particular demo. Okay, but the same project, you can clone it into your repository and then you can work it out. Right. So now let's see how to write a Docker file in order to Dockerize the normal Java application. So firstly, we know that any Docker file will start with a keyword which is known as Tomcat. Okay, any Docker file will start with a keyword which is known as Tomcat. But before writing the Docker file, let me explain the Docker file concept that is directly available in the GitHub repository. You can see this is the repository that is available. You can see there is a Docker file that is available. Click on Docker file and you can see the Tomcat is something that I'm going to use as a base image. Why I'm using Tomcat? Because I want to deploy my application into the Tomcat. Since I need Tomcat as the base image, I'm using from keyword in order to deploy the Tomcat. That's basically called as using the official Tomcat base image. And then we know that the Tomcat web server will run by default on port number 8080. The Tomcat web server will run on port number 8080. Since I want to access the Tomcat, I am using expose keyword. Okay, I'm using expose keyword space the Tomcat port number. In the last session, if you remember, we have understood Python applications will by default be accessible in the port number 5000. Whereas Tomcat port number, default port number of Tomcat is the 8080. And then I am going to copy the var file to the web apps directory of Tomcat. In the Tomcat, we have a directory which is called as web apps. All the var files which are getting generated, they should be deployed into the web apps directory. So for that, I am using the copy keyword, where by default, when you execute maven goal, that is mvn clean package goal, the var file will get generated into the target folder. Okay, this is the var file name. You can give any var file name here. I'll talk about this var file name in some time. Now here what I am doing is whatever the var file that is available in the target directory, I am going to copy that var file into the directory which is available inside the Tomcat. What is the directory name? Web apps is the directory. Okay, this will be the default directory that will be available inside the Tomcat. So this is how I'm going to use the Docker file in order to Dockerize the normal Java application. So you can see I have given the same thing here. When you are practicing, you can give it the same thing. So copy from base image, that is Tomcat I want to deploy. So I'm using Tomcat as the base image. Expose, I'm using Tomcat port number, that is default port number of Tomcat, which is 8080. And then I want to copy the var file to the web apps directory. So currently where that var file will get generated, it will get created in the target folder. Whenever you execute the maven goals, the var file will get created in the target folder. This is the var file name. So this var file, what I am doing, I am copying it to a directory which is known as a web apps directory. Where this web apps directory is available, it will be available inside the Tomcat. Okay, it will be available inside the Tomcat. Now here you might have a question, how this Tomcat will come? It is going to come because we are downloading the base image of Tomcat. Okay, we are downloading the base image of Tomcat. Now here, the var file name, you can change according to the var file, whatever that you are going to get generated. Okay, right. So this is how you can work with the Docker file of Tomcat. Now here, what we need to understand is where the Tomcat server is installed, it is getting installed inside the container. That is why I'm mentioning in the Docker file. So this Tomcat will get installed inside the Tomcat, inside the Docker container. So here what we are trying to do, we are trying to Dockerize the application on the host machine. Okay, we will always try to Dockerize the application on the host machine. What is our host machine? Linux EC2 instance. In the host machine, what I have done, I have installed the Docker. Okay, in the host machine, I have installed the Docker. Then what I am going to do by using this Docker file, okay, I'm going to build the Docker image. Once the Docker image gets created, then I am going to create the container that's called as a Docker container. Inside the Docker container, what will be available? Tomcat web server will be available. Okay, inside the Docker container, Tomcat web server will be available. Inside the Tomcat web server, what will be available? My application will be available. What is that application? The normal Java application. Okay, the normal Java application. So that's why I am mentioning the Tomcat in the, if you see the Docker file, I am mentioning user local Tomcat I'm mentioning. Where the Tomcat is running, it is running inside the container. Okay, it is running inside the container, right? So this is the Docker file that we can use in order to work, in order to Dockerize the normal Java applications. So let me connect it to the EC2 instance where I have already installed the Docker. In the previous session, I have already deployed the Python-based application. I hope you have followed the previous video. In the same EC2 instance, I am also going to Dockerize the normal Java application. Okay, I'm also going to Dockerize the normal Java application. Currently, you can see I have connected to the EC2 instance. Let's verify whether Docker is running or not. So Docker is actually not running because I have stopped it. So let's start the Docker service. So how will you start the Docker service? Sudo service Docker start. If you click enter, you should see the Docker service should get started. Once the Docker service gets started, let's verify whether Docker status is active and running or not. You can see Docker is currently active and running. If you remember, in the previous session, I have created one Docker image which is related to the Python. So let's verify whether the Docker image is available or not. You can see Python app is the image which I have created. Okay, Python app is the image which I have created. And then if you also remember, I also have the container. So if you want to see the list of running containers, Docker PS, you can see there is no container that is in the running state because I have stopped that container. If you want to see the list of all the containers, Docker PS-A, you can see the container is available and it is in the exited state. Okay, you can see the container is available and it is in the exited state. By using which image I have created the container? By using the image called Python-app. Right. So now if you do ls, you can also see the Docker Python project, which I have used in my previous session. Okay, which I have used in my previous session. Now what I will do is I will clone the repository that is available here. Okay, I will clone the repository that is available here. So maven-app-1. This is the repository that I'm going to use. So just how will you clone a repository? Just copy the Git repository URL and then go to the mobile extension. So before that, let me see whether that repository is available or not. So my-docker-app. Okay, this is not something that is required. So let me clone the repository. So how will you clone the repository? Git clone we have to use. Before that, can we install the Git or not? Yes, we have to install the Git. Currently, Git is already installed in my EC2 instance. You can check Git is available. And then we also have to install Maven. Okay, we also have to install Maven. Why we need to install Maven? Because we need to package the code. Okay, we need to package the code as a what file? As a var file. Let's see whether Maven is available or not. MVN space -- version. You can see Maven also I have installed. Okay, Maven also I have installed. So how will you install Git and Maven? So to install Git, okay, to install Git, the command is sudo yum install. Okay, sudo yum install git-y. This is the command to install Git. Now, if you want to install Maven, okay, if you want to install Maven, the command is sudo yum install maven-y. Okay, sudo yum install maven-y. By using these two commands, you can install both Git and Maven. Right. So let me clone the repository. So for that, let me copy the repository URL once again, and then let me go to the mobile extension. In the mobile extension, I'm just giving git clone space the repository URL. So I'm just pasting the repository URL, and then there will be a repository that gets created, which is known as maven-app-1. Let's see that. So currently, let me give ls. You can see maven-app-1 has got cloned just now. Now let me switch to that particular directory, cd space maven-app-1. You can see I'm there in the maven directory, that is maven-app-1 directory. You can see the present working directory. And inside that, I have the Docker file, I have the pom.xml file, python.py file, it's not required. So it's just a simple file which is not having any data. So even if you don't have also, nothing is a problem. And then src target folder, right? So now what we have to do, we have first cloned the repository. Okay, we have first cloned the repository. And then what I have done, I have went inside that cloned repository. Okay, I have went inside that cloned repository. Now what we will do, we will do the maven goal execution. Why we need to do the maven goal execution? Because we want to package the application. Okay, because we want to package the application. So if you want to package the application, we need to execute a maven goal, which is known as mvn clean package. What does clean goal will do? Clean goal will delete the existing target folder. Okay, clean goal will delete the existing target folder, and then the package goal will create a new target folder where inside the target folder, the war file is available. Okay, inside the target folder, the war file will be available. That is the reason why I have mentioned copy target/war file name. Okay, where the war file is available inside the target folder. So whenever you are working with Java applications, it's mandatory to execute the clean package goal. What does clean goal will do? If there is a target folder, it will delete the target folder. What does package goal will do? It will create a new target folder where inside the war file will be available. Okay, the application war file will be available. So let's do the clean package goal execution so that the build will get success. Once the build is success, we can see where the war file got generated. Can you see building war, where the war file got generated? /home/ec2 user /maven-app-1 target directory. Inside the target directory, the war file name is available. Okay, inside the target directory, war file is available. So how come this war file is available here? How come the name of the war file is available here? This I am mentioning in the pom.xml file. For every normal Java applications, you will have a pom.xml file or pom.xml file. If you open this pom.xml file, you can see I have given the app name. Okay, you can see final name. I have given the app name as Kastro-app. Whatever name that you give here, okay, whatever name that you give here, with the same name, the war file will get created. You can see Kastro-app, and here also you can see the war file name, that is application name, that is Kastro-app. So whatever name that you give in the pom.xml file, the same name you can also see it here as well. The war file got generated. Right. Now, once the war file got generated, can I create the image? Can I build the image? Yes. So how will you build the image? Let me first build the image. So what is the command to build the image? Docker build -t space image name. Let's say I'll give the image name as Kastro-app. Okay, Kastro-app, and then give dot. You can give any image name you want. Okay, you can give any image name you want. There is no problem that you should give only this name. You can give any image name. So let me click enter so that the Docker image will get built. So here, if you see, I have used the Docker build -t and then image name. That this image name can be anything and then space dot. But here, if you observe, there is one thing that is showing it as an invalid argument, that is Kastro-app. What it is telling, repository name must be lowercase. Okay, whatever name that you have given here, it must be lowercase. So it should not be capital letters. So let me give this one Docker build -t and then Kastro-app space dot. Now the Docker image is getting built. This is one thing that I want to tell you from this particular thing. So when you are creating the images, the image name should not be in capital letters. They should be in small letters only. So when I gave the small letters, you can see the image is getting built. Once the image has got built, then what we can do, we can verify whether the image got created or not. So how will you verify whether image got created or not? Docker images, you can see Kastro-app image has created 9 seconds ago, image ID, the size of the image, and the tag for the image. Now currently we have the image. Okay, we have the image. Now what we have to do, we have to run the Docker image. Okay, when we run the Docker image, what will happen? The Docker container will get created. Okay, Docker container will get created. But if you remember in the last session, whenever you want to run the image, okay, whenever you want to create the container by using the Docker image, what we need to do, we need to specify the port mapping. Okay, we need to specify the port mapping. What is meant by port mapping? What is the need for port mapping? That we have discussed in the last video, where I have talked about mini project one, that is Dockerizing the Python based application. So you can watch that previous video to know more details about the port mapping, the concept of port mapping. Now let's run the image and do the port mapping. So how will you run the image? Docker run is the command to run the Docker image. And then -d. -d represents detached mode. And then -p. -p represents port mapping. Now, first, what you have to do, you have to give the host port number. Okay, host port number. Docker will run on which port number? 8080. And then container port number, which is 8080. So container port number, you cannot change. Okay, container port number, you cannot change. You can change the host port number. So suppose, let's say I want to change the container port number. If you want to change the container port number, in the Docker file, you have to give that expose. Okay, in expose, I have given port number 8080. So whatever port number that you have mentioned in the Docker file, the same port number you have to mention in the right side, which is container port number. If you want to change the port number, you can change it here, and then you can change in here itself. But this port number is something that you can give any number. Okay, that you can give any number. So this is called as a host port number, and this is called as a container port number. So we have already talked about what is -d, what is the importance of this one, what is -p, what is its important, what is container port number, and what is host port number. So we have already seen that. Remember, left side one is a host port number, right side one is container port number. And then give the image name. What is my image name? Kastro-app is the image name. Once you do this, what will happen? The Docker container will get created. So let me click enter. You can see the Docker container has got created. If you do Docker PS, you will see the Docker container is running, which got created by using this particular image. So let me clear the screen. Now our Docker container is available. Okay, our Docker container is available. Can I access the Docker container? Yes. How will you access the Docker container? In order to access the Docker container, first you have to open port number 8080 in the security groups of EC2 instance. You can select the EC2 instance, go to security. In the security, click on the link, and here you should click on inbound rules, and then you should open port number 8080. Currently, I have opened the port number 8080. Source, you should give it as anywhere IPv4, and then click save rules. If you remember, in the port number 5000, our Python application is running. In the port number 8080, what I'm going to do, I'm going to run the normal Java application. So let's verify whether we can access the application or not. So click on save rules, and then copy the public IP address of the instance, and then go to the new tab. Okay, copy the public IP address of the instance, go to the new tab. In the new tab, paste the IP address :8080. Why it is 8080? Host port number. Okay, it is 8080, which is host port number. And then slash, you should give the war file name. What is the name of the war file? If you see the war file name, where the war file will be available inside the target folder. So how will you know the name of the war file name? So first you should go into the directory and then give ls. You can see the target folder. If you go inside the target folder, cd space target, inside the target folder, the war file will be available. What is the name of the war file? Kastro-app. Whatever is the name of the war file, that you should give it here. Okay, whatever is the name of the war file, that you should give it here. So Kastro-app and then slash. Once you do this, just click enter so that you will be able to see the application. Remember here, you should give the Kastro-app. What is Kastro-app? It's not an image name. It's the war file name. Okay, it's a war file name. So here, when you are trying to access the application, you should give the war file name. That's most important, not the image name. So I'm clicking enter now so that we should be able to see the application that we have created. So Kastro-app. So let me see the public IP address of the instance once again. So copy the public IP address and then go to new tab. In the new tab, paste the public IP address colon 8080 slash Castro hyphen app. Click enter. You can see the application is available. So what is this application? This is a Java based application. This is basically the normal Java application. If you remember in the last session, I have also created Python application in the same EC2 instance only. Now in our EC2 instance, in this EC2 instance, how many containers are running? Two containers are running. What is the first container? Python related container. The second container is normal Java application related container. So in the same EC2 instance, can I run multiple containers? Yes, it is possible. If you remember, in the very beginning sessions of Docker concepts, I have told that in a single EC2 instance, we can run multiple containers. So are we able to run the normal Java application related container and Python related container? Yes, we can run. So here, let's say I have the application. Okay, I have the Python application also. Now I want to run the Python application as well. How will you run the Python application? So just paste the IP address, colon, Python application is running on which port number? 5000. And then click enter. But before clicking enter, can you verify whether Python is running or not? Python container is running or not? Yes, we have to verify. So let's verify Docker PS. And here you can see only the Java application related container is running. Let's verify. Let's start the Docker container, which contains the Python application. You can see this is the Python application. So how will you start the Python related container? So what we have to do is first let's verify whether Docker container is running in the running state or not. So how will you verify Docker PS? You can see currently I have only the Kastro app where Java application is running. That is normal Java application is running. But what about the Python application related container? You can see the status of the Python application related container is it is in the stopped state. So let me start the container which contains Python application. So how will you start a container? Docker start space container ID. So copy the container ID and paste it here so that the container will get started. If you execute Docker PS, you can see two containers are running. First container, that is Java application related container, it is running on port number 8080. And then the second container is Python application related container, which is running on port number 5000. Now, can I access the container? Yes. So let me go here and then click enter so that we should be able to see the Python application. So currently, if you see here in one container, that is 8080 port number, my Java application related application is running. And in the port number 5000, my Python application is running. You can see this is the same Python application that we have deployed in the previous video. In this video, we have understood how to deploy the Java application, which is basically developed without using the Spring Boot framework. So what kind of application? We call it as normal Java applications. Okay, this is called as a normal Java application. And this is the Python application. Port number 5000, Python is running. Port number 8080, the normal Java application is running. That's basically called as a legacy project. So this is how you can Dockerize multiple applications in the same EC2 instance by creating multiple containers on top of the same EC2 instance. In this video, we have understood how to Dockerize the normal Java applications which are created without using the Spring Boot framework, which are called as a legacy project. And here we also have to understand both the Python application, which I have created in the previous session, and the normal Java application is running in the same container. In the next video, we are going to talk about the mini project 3, where I'm going to show you how to deploy or how to Dockerize the Java application, which is developed using Spring Boot on the same EC2 instance. Then we will understand the clear difference between how to Dockerize the different applications which are developed by using different programming languages. Thank you.